Hi, this deck of cards is compiled in order to facilitate getting through the passage Thermodynamics of gallium arsenide formation. Okay, and most of the content in this particular stack is concerned with chemistry more so than physics. All right, so we're dealing with more of the chemical aspects of biological systems. What is the atomic number? All right, let's get to it. For gallium, what is the Z for gallium? Okay. The atomic number for gallium is 31. So it's the 31st element on the periodic table. A few asides about gallium is that it's a p block element. It's in main group 3A. So since it's a p block element, it falls on the right-hand side of the periodic table, and it's situated right along the cusp between metals and nonmetals, so it's considered a poor metal. All right. What is the chemical name for quartz? What is the chemical name for quartz? Silicon dioxide. Okay, let's see. So the chemical name for quartz is silicon dioxide. What is the electron configuration for gallium? Remember previously I said it's a p block element, so the valence electron has to be in the p orbital. Let's see what it is. So the electron configuration, well, the core is the same as argon. Okay. So now we have the 4s orbital that gets filled. And what you have to note here is that argon has 18 electrons total. So argon has 18 electrons. Okay, so this is the way we can check ourselves, because at the end, the total number of electrons has to add up to 31, since the Z for gallium is 31. And then we have 3D. So for anybody that might be perplexed, the 3D orbital gets filled up before the 4p orbital. Okay. I know it's weird. It's just something that you have to memorize and get used to. And then we have 4p. So there's only one valence electron in the 4p orbital. Okay. So let's check. There should be a total of 31 electrons. So we have 18 plus 2. It's going to give us 20, plus another 10. That's going to give us 30, plus the last one in the 4p shell. It's going to give us 31. What is the order of the valence electron is in the p orbital, so that seems correct. And this is in terms of increasing energy. So I'll give you a moment to think. The order is going to be 1s, 2s, sorry, 2p, 3s, 3p, and notice that the 4s orbital gets filled before the 3d orbital because it's of a lower energy state. So you fill up the 4s and then you fill up 3d. All right, this is one that often confuses people, or they tend to forget about it. So remember that 4s gets filled up before 3d. And finally, 4p. What is the molecular formula for gallium 1 oxide? And the 1, this is a Roman numeral 1, denotes the oxidation state of +1 for gallium. Okay. So the molecular formula is Ga sub 2O, and it occurs as a solid. And so the easy way to do this, to figure out, the relative ratio, stoichiometric ratio of each element, is to use what I call the crisscross method. There might be a formal name for it. I'm not really sure. So we know the typical oxidation state for oxygen is usually +2. And we're told, that it's gallium 1 oxide. So we know that the oxidation state is going to be -1. So all you have to do is crisscross. You put this coefficient down here, put this coefficient right there, and there you have it. 1 is usually implicit. I said oxidation. Molecular formulas, it's never really oxidation written. State, that's a tongue twister, is usually blank. I think I just told you. What is it? All right. Oxygen's oxidation state is usually +2. I wrote -2. It's really supposed to be +2. Metals have negative oxidation states, whereas nonmetals have positive oxidation states. What is the molecular formula for elemental arsenic? The molecular formula for elemental arsenic. All right. So it's As sub 2. So arsenic is a diatomic element. And it's right on the cusp between metals and nonmetals, but it is classified as a nonmetal. And what is in its diatomic state? It occurs in the gaseous form. Not gallium 1 oxide, I should say, to be more precise, more correct. Gallium oxide. All right, so the oxidation state for gallium oxide is, the molecular formula for gallium oxide, I might have said oxidation state, is Ga sub 2, O sub 3, and this is a solid. And now remember before I showed you the crisscross method, so the common oxidation state for oxygen is 2, +2, and gallium is a metal, so it's going to have a negative oxidation state. And on the MCAT, you are allowed to use your periodic table. And if you look at the group that gallium's in, it's in main group 3A, if you ignore the transition metals in between the main group elements. So it's most likely going to have an oxidation state of 3, and you just crisscross the absolute values of these things, of these elements, to get, their molecular formula. What is the molecular formula for gallium arsenide? Gallium arsenide. All right. So it's just going to be GaS. Okay. So this is gallium when it has an oxidation state of 1. And arsenic is a group 7 element, meaning it has a +1 oxidation state. And earlier you saw that gallium can have a -1 oxidation state. So it's not specified that it's gallium 1 arsenide, but that's what it is basically. And it's a solid, okay? Because it a metal plus a non-metal makes what's called a salt, not just, table salt, NaCl. That's just a generic name for the combination of a metal and a non-metal. Okay, so what is Gibbs free energy equation? Now there are several ways that you can equate Gibbs free energy, but the Gibbs free energy equation has very specific variables. So I'll give you a moment to think. All right. So here we have delta G equals delta H minus T delta S. Delta H is a change in heat or internal energy, and delta T delta S is the entropy term. So you have the change in entropy, okay, multiplied by temperature. And temperature is usually in Kelvin, or if you're dealing with like, I don't know, some other weird units, it's in Rankine, so temperature has to be absolute. Okay. Okay, so delta G equals blank T, the natural log of K. Delta G equals blank T, the natural log of K. All right. Delta G equals -R, where R is the universal gas constant. Okay. And that's in that joules per mole Kelvin, and has a magnitude of 8.314 because there's another version of the universal gas constant. And T, okay, that's the temperature in Kelvin again. And the natural log of K, where K is the equilibrium constant of whatever reaction you're looking at, the reaction of interest. Okay, so that's the equilibrium constant. All right,